Hi, my name is Eric Dillon. I'm with the JSOG Training Center in Fresno, California, and today we're going to talk a little bit about subcooling. So some of you may be thinking, well, I already know how to do subcooling, and that may be true. We're going to break it down a little bit simpler today, and unfortunately, just like with our superheat video, a lot of you guys are using these. We're not going to use these today. We're going to get rid of these. We're going to do it the old school way. So first we want to talk a little bit about what exactly is subcooling. And put simply, subcooling is any additional cooling that we can apply to our refrigerant out of the condenser side. As it's converted back to a liquid, it's reached its saturation point. Any additional cooling that we can get out of that before it actually exits the condenser is our subcooling number. So let's spend a second and let's talk about our temperature-pressure relationship. We really got into this in the superheat video. If you haven't seen that, please go back and check that out. But all of our refrigerants will have a temperature-pressure relationship, and this is a handy little chart that has multiple refrigerants on there. And as our pressures increase in our refrigerant, we increase the pressure, the temperature will increase. If we decrease the pressure, the temperature will also decrease. And so they move up and down together, and that's that temperature-pressure relationship. For today's activity, we're actually using a set of gauges that have the 410A temperature pressure chart already built into the gauge, and this one also has 404A and R22, and a lot of these old analog gauges, they will have that. If you're using the digital gauges, of course they're programmed, it's all programmed in there, and it's a little easier for some. I prefer the old school methods because I like to get my hands dirty. Okay, so when we're going to talk about subcooling, we want to have a very accurate way of measuring the actual line temperature. We want to get the actual refrigerant temperature as close as we can. So if you're using an infrared, that's not the best way because you have air around it and in between. So we always recommend the use of a good clamp on. And we're going to show you real quick where to put this. The proper location for measuring subcooling is going to be outside of our condenser, which is this line coming down here. And as you can see, we have a filter dryer here, but we want to be before the TXV. And since this is a package unit, obviously we only have a very small spot there, but this is where we want to get our reading. And that's going to give us our actual temperature, our best temperature reading that we can get. And we want to make sure we're always after that filter dryer when possible, because if that thing's plugged up, it may actually be metering a little bit and throw your numbers off. And this is just a standard K-type connection. And we're just going to plug that into our meter, and we're going to set this to temperature, and I'm going to turn on the unit, and we'll do some measurements. So we have our unit fired up. We've got everything hooked up. I previously had our gauges already hooked up. And so we're running about a little over 200 PSI, which is going to give us, on 410A, it's going to give us a temperature of around 72, 73 degrees. And so as you can see over here, we're actually reading about 67.5 degrees, right? So that difference, if we subtract our physical temperature from what our saturation temperature is, or what our temperature pressure chart would tell us, we subtract the actual from this, that gives us our subcooling number. Obviously this is a little bit off. We're in our lab. It's a little cool in here, and we have the same condenser air and supply air, or our return air temperatures are the same temperature, so we don't get an accurate number of what you would see in the field. But in a nutshell, it's just simply, if you can understand that we have our saturation pressure, or saturation temperature, right? Subtract that, your actual physical temperature from that, and that is your subcooling number. And probably one of the key things is you have to understand that, you know, that temperature pressure relationship, they're going to go up and down together, right? So any additional heat that we can remove through our condenser process, we're after that, right? We need that subcooling number in order for these systems to operate properly, not only properly, but efficiently. All right, so we've shut the unit back off just so that it's easier for you to hear me. A couple of things I want to touch bases on is sometimes there's been some confusion as far as using subcooling as a charging method. The first thing I'm going to tell you is understand what the manufacturer of the piece of equipment that you're working on, what do they want? A lot of times they'll have published charts, sometimes in the books that come with the unit, or you can always find this stuff usually on the internet. But understand what they're after, and because the subcooling, just like superheat, different manufacturers may require slightly different numbers. So understand what your target is so that you can achieve it. You don't want to just call it good enough and have problems down the road. Okay, so hopefully this helps you get a little bit better understanding of what subcooling is. For this and any other training needs, don't be afraid to come see us at the JSOG Training Center in Fresno, California, where we provide you with real-world experience for your real-world career.